Hi folks, we're going to take a look at number 11 from the Unit 5 assignment. So let's start by reading the question. So here you have Jen and Barry live on the same street, 900 meters apart. Jen leaves her house and walks to Barry's house at a rate of 2 meters per second. And at the same time, Barry leaves his house and walks towards Jen's house at 1.5 meters per second. How long will it take for them to meet along the way? And they tell us that they want us to do it by solving a system of equations. Okay, so first of all, we got to figure out what it is we're going to be comparing. So here, obviously, time is going to be one of our variables. And since they're walking and we want to know at what time they want to meet, we should also be talking about the distance that they're traveling until they meet. Okay, so because there's a certain geometry to this problem, I'm going to use a picture to hopefully help me figure out what the equations are going to be. Okay, so let's say this is Jen's house and this is Barry's house, and they live 900 meters apart, and we'll assume that's the direct distance from one house to the other. Okay, now if we want to measure distance, remember when we're solving a system of equations, we need the two variables in each equation to represent the same thing. Okay, so we'll let time, that's easy, let t be time of travel. Okay, not really much to think about there. But in terms of the distance, how are we measuring the distance? In other words, from where are we measuring it? Well, we have, I would say, two obvious choices. One would be measuring the distance from Jen's house, the other measuring the distance from Barry's house. Okay, so you can solve this problem using either one. I'll use Jen's house as the point of reference. So we're going to let D be the distance from Jen's house. Okay, now that we have our variables, let's try to write an equation. Okay, so what's Jen doing? So let's start. Equation 1 will be for Jen. So Jen starts at her house and is moving away from her house, okay, at a rate of 2 meters per second. Okay, now since her distance is getting larger, okay, as she moves away from her house, the distance from her house is getting larger, so that rate of change should be a positive one. Okay, so we have our distance equals, well, rate of change represents, well, slope, so m times my variable, so it's going to be 2t plus b. Now remember, b represents the y-intercept, or the initial value, but Jen's initial value would just be 0 because she's starting at her house. So at the beginning, she's 0 meters from her house. Okay, so this would be like plus 0, which of course we don't write. So there's our first equation. Now let's write an equation for Barry's motion. So distance, now his speed is 1.5 meters per second. Okay, but remember, we're measuring the distance from Jen's house. So as he's moving towards her house, his distance is getting smaller. Okay, and this is the trick to doing this question right, is because his distance is getting smaller, excuse me, okay, we're going to need a rate of change or of slope that's negative. So it's going to be negative 1.5 t. Okay, so just to recap, his distance from her house is getting smaller. So anything that's decreasing needs a negative slope. Plus, and his initial distance is 900 meters from her house. Okay, so plus 900. And here we have our system of equations. And it's a really nice one because variables are already isolated. Sorry again. So here from the first equation, I know that d is equal to 2 times t. So I'm going to substitute that into the other equation. Wherever I see d, I'm going to replace that by 2t. Okay. And now I just solve my one equation and one unknown. So bring the negative 1.5t to the other side. It becomes 2 plus 1.5t. So that's going to be 3.5t equals 900. And so t is going to be equal to, get a calculator out. Okay, 900 divided by 3.5, which is 257. Okay, 257, and we see here that the time unit is seconds, so 257 seconds. Okay, So that's how long it's going to take for them to meet. Now, if you don't want to leave your answer in seconds, well, you can also give it in minutes. Okay, so we know that there's 60 seconds in each minute, so let's divide this by 60. Okay, so 4 whole minutes are in there. Okay, but I don't want 4.28 seconds. 4.28 minutes. I'd like to write it as 4 minutes and a certain number of seconds. Okay, so one way to do this is to say, well, 4 minutes is 240 seconds, so 257 has an extra 17 seconds. So 4 minutes and 17 seconds. Okay, so just to recap here, so the idea was to determine what variables we were going to be working with, in this case here distance and time. Okay, the next thing was to write equations. Okay, and I would say the trick in this one here had to do with the slope of the second equation. That because Barry's distance was decreasing with respect to Jen's house, we needed that negative in front of the